This is my reassessment for work energy. This is problem number 58 of chapter 6. A block of wood is compressed 2 nanometers when inward forces of magnitude 120 newtons are applied to it on two opposite sides. Assuming Hooke's law holds, what is the effective spring constant of the block? Assuming Hooke's law still holds, how much is the same block compressed by inward forces of magnitude 480? And how much work is done by the applied forces during the compression? So, to start off, we convert 2.0 nanometers to 2.0 times 10 to the negative 9th meters. Our starting force is 120 newtons, and that's our starting compression length. Once we plug it into the formula, the spring constant is equal to the force divided by the compression length. You get 120 newtons divided by 2 times 10 to the 9th meters. And that comes out to a spring constant of 6 times 10 to the 10th Newton. Newton divided by meters. So part 2, we're looking for the how much was the compression, which is x, and once we rearrange the equation, and we get the force divided by the spring constant. So we take the spring constant that we found in part A, plug it in here, and then our new force is 480. When we solve, we get 8 times 10 to the negative 9th meters are equal to x. And then right here it wants the total work done on, or not the total work, but how much work is done by the applied forces. And so this is our formula, with k being the spring constant and x being the compression length. And so we plug in our spring constant, 6 times 10 to the 10th Newton per meter, times 8 times 10 to the negative 9th meters, our compression constant, squared, and this is all times 1/2, which gives us 1.92 times 10 to the negative 6 Newton meters, or joule.